All right, hello. So recently, I've been making this Desmos graph. And the point of this Desmos graph is to help you get onto the right track when you take Canvas quizzes. Now, this only applies to Canvas quizzes where you have a second attempt and when you can see information about a question as shown in this picture right here. So if you are given the amount of points you got out of the total amount of points, and then how many answers there are and how many answers you chose, as long as you can access those four things about a previous attempt, you can use this technique. So the way this works is on this graph, the x-axis is the number of false positives, and the y-axis is number of false negatives. False positives are answers you chose, but they weren't actually correct. False negatives are answers that you didn't choose, but they were actually correct. And so you can read this y-axis as 0, 2, meaning that, for whatever question this is representing, the person has two things that they didn't answer, but they should have. This is not applying to this question. This is just a previous one. But let's modify this graph so that it refers to this question. Now all you need is total number of answers in the question. There's 4. So let's change that to 4. How many answers you chose? We chose 4. Total possible points. We can get 2 points possible from this answer. And then it asks how many points did you actually get? We got 1.33. And so now you can see there's this little line at 1, 0. Now it's a good thing to call back to how x and y are number of false positives and number of false negatives. So while this line is continuous, the majority of its coordinates are not meaningful, because number of false positives and number of false negatives, well, both of those can only be whole numbers. You can't have like 1.5 answers that you didn't choose. You can only have integer valued coordinates. So when you see a line or an area in this graph, you're only concerned with the integer coordinates contained in the line or the area. So in this case, we have 1, 0. That's all we care for. That means we have 1 false positive and 0 false negatives. So if we recall, that means that we have one answer that we chose, but it's not true. And we have 0 questions that we didn't choose. We had no more left to not choose. So this essentially means that the only way to get 1.33 out of 2 points is if you answered one of these incorrectly. And so that would also mean that this answer has a total of 3 correct answers. And so if I go to the next question, or the results of the question rather, you can see that yes, there were 3 correct options. The wrong one happened to be option D. And I got 2 out of 2 points for it. And it's also, maybe it's worth mentioning, these are screenshots. So this was an actual test question I got in one of my classes. I just modified the actual web page itself via the HTML so that you can't really see anything about the class or the quiz. I did that just for student conduct violation avoiding. So yeah, nothing here. You can't extract any information from these pictures that would give you answers to a quiz in your class or something. So yeah, maybe let's go into the next example. So the next example, question 1. This one is also one of the quizzes I took week 1. I'm currently in week 7. And in this example, we got 1 out of 2 points, and we checked 2 of these boxes. So let's go ahead and fill these out. How many total answers? There's 5 total answers. That should be option E. That's just a typo. 5 total answers. How many answers you chose? I chose 2. How many total possible points? I can get 2 points possible. And then how many points did I get? I got 1 point. And so again, there's a lot of different XY pairs on this line, but we are only considering the ones with integer values, whole number XYs. And the only one that this line has is 0, 2. That means the only way you can possibly get 1 point out of 2 on this question is if there's 2 options that you did not select. There's no other variation of this question where you can get full points. It has to be that you missed 2. That also means that the 2 you selected are 100% guaranteed to be true. Because of the 0 in the X, you have 0 false positives. That means you had no questions that you chose that weren't correct. And so now we can go to the results for that question. And lo and behold, I got 2 out of 2 points, and there were 4 correct options. Now, you can see like, oh, in this one, option A wasn't selected, but in the previous one it was, and I just said that like, oh, option A is guaranteed to be true. For the Canvas quiz itself, the answers were shuffled. So option A from the previous attempt was one of these. So yeah, this technique, this Desmos graph that I created, it doesn't give you the correct answers. It just tells you, or it pushes you in the right direction on what to look for. Like for example, the only information I could extract from this is that 2 of these 3 options were correct. And so I still had to, have some value added, just from my knowledge of the curriculum. I had to know which questions to answer. So it's not exactly like a freebie on a quiz. It just pushes you in the right direction. And if you don't know this stuff, this isn't going to help you that much. It just essentially reassures those who have a good understanding of the content. So, moving on to the last example that I have, you can see that we got 0 out of 2. And so you'll see that something weird happens when you get 0 points. Let's just fill this out. Number of total answers, there's 3. I answered 2. There's 2 possible points. And now watch what happens when I put my points to 0. So far it's so good. And then, oh, it's an area. It's not a graph, or it's not a line, it's an area. What does that mean? Well, it's the same thing. There's a lot of different XY pairs that you can pull from this, but we are only concerned with the ones that are integer values, whole numbers. So that would be 1, 0, 1, 1, and 2, 1. Now the reason that there's all of a sudden, a jump to a bunch of different possibilities, the reason is because when you get 0 points, it's really ambiguous. Just because Canvas doesn't, if you actually got negative points for this question, Canvas just slaps on a 0. So I'm unsure of the actual points you got on the question because they could have been negative. And just to explain how Canvas grades wrong answers, let's see if I can zoom in here. Okay, well I can't. Let's see, can I just full screen it? There we go. Canvas, let's say that option C is a correct answer. That means you get plus a certain amount of points towards the question. If option B was wrong, you get minus C. So you lose the same amount of points for choosing an incorrect option that you would instead gain if you chose a correct option. C is the same number in both cases. So if option C was true and option B was false, then yeah, we would have got 0 out of 2 points because these C's cancel out. But we don't know that for sure. Let me show you another example. What if both of these were false? Then that would mean each one is minus C minus C. So that means your true points that you got for this question was negative 2C out of 2. And then what Canvas did was it just says, oh, we can have negatives, so it's 0 out of 2. So you can see that there's two avenues. There's actually many more, but there's the two avenues I showed you is that there's multiple ways you can get a 0. And when you have something greater than 0, you lose this ambiguity and you can be more specific with the line. But when you get to 0, there's a lot more possibilities that can happen. So that's why it's pretty vague if you have 0 points on a question. But if I go back to this graph here, I have it written down that you can use a question when you got 0 points on it. You can't really use this graph to infer how to answer the second one. There's just too many options. It's going to pretty much just rely on you knowing the curriculum and guessing correct in the first place. But what you can do is that the correct answer, if you transform this current attempt via one of these coordinates, the correct answer can be found via one of these coordinates. So I have it written down here. After you answer the question in your next attempt, there must be a way you can get to your new answer from your old answer via one of these intersections. So you can't really use this graph to determine what you can in other questions about, your next attempt. But when you answer the next attempt, you can use this graph to check your answer and be like, okay, can I derive my new answer from my old answer via one of these coordinates? And if you can, then you should be good. You can still get it wrong, but you have a much higher likelihood of getting it right if you can follow what I just said. Okay, but enough talking. Let's actually get to answering the question. If I go to the actual answer, you can see that there were 2 options correct, and I got 2 out of 2 points. So for this question, there were 2 options. That means that the correct intersection was 1, 1 right here. And the reason being is that 1, 1 represents the fact that in this attempt, you had 1 false positive and 1 false negative. So that means that you had 1 question or 1 answer that you chose that isn't actually true. And there's 1 answer that you didn't choose that actually turned out to be true. And so in this case, that would just be this one guaranteed. And then you essentially swap it in for one of these 2. So that's what, that's how you can derive the answer from a previous attempt. Cool. And so I think that's good enough for explaining. There's this little note in here that says the graph can be wonky sometimes. Sometimes you can see the area or line jitter if you move the graph like this. And so if you move the graph, there is a possibility that you unlock other possibilities you'll see what I mean when you come across a problem where if you just drag the grid, something will change about this. That's just something to do with Desmos. Can't really fix that in any way. But yeah, the entire equation is actually just this first part. All of these things inside brackets are just boundaries. These essentially prune the possibilities that the coordinates can be to the point where the ones shown are they are guaranteed to be valid ways to transform your answers into a new attempt. But yeah, I'm gonna show a quick derivation of this equation. In case you're curious, it's much simpler to understand than you might think. I'm going to have another video that goes more in depth into everything. So if you're interested in that, the link will be in the description. And the Desmos graph will also be linked in the description if you want to use it. Yeah. Okay. So, let's define some variables here. So let's say P, that'll be the total number of points possible. Okay, that's a T. P will be the total number of points that you can possibly earn from the question. B will be the points you got. And then let's let N equal the number of answers you chose. And I guess a thing I should note here, answers does not imply that you got them correct. It's just the ones that you checkboxed, the ones that you marked. The number of answers that you marked is N. And then is there anything else? Let's define X and Y. You already know what Y's and X's are. X's are false positives. And Y's are false positive. Okay, so without further ado, let me just shrink this a little bit. Hopefully you can still see that. Let me fix that F. All right, so everything stems from this equation. Imagine an equation where you have the total number of points you can possibly get, and then you subtract the something. For now, I'll just put something, and that's how you got the number of points you got. So P minus something equals the points that you got. So the key here is, what is that something? That something is the number of wrong answers. I'll just say number wrong times the cost of getting it wrong. And so as you remember from my previous example, Canvas grades it so that if you get a correct answer, it's plus C. If you get a minus answer, it's minus C. But we're just curious about not the sign of C. We're just curious about C itself, because we're subtracting the total number of points that we lost. Yeah, we're subtracting the total number of points that we lost just by multiplying the number that we got wrong times C. And so then let's rewrite the equation. The number wrong times C. And that equals the points that you got, B. And so now we can look at how do we represent the number that you got wrong? How many answers did you get wrong? Well, it might be confusing at first, but it is just X plus Y. The number that you got wrong is just X plus Y. And that would make sense because X is the number of false positives and Y is the number of false oh, whoa, okay. Negatives. All right, that's my bad. Wow. All right. So Y is the number of false negatives. When you sum them together, you get the sum of the total number of answers that you got wrong. And that's exactly what we need. And so now we need C. What is C? So C, let me show you an example of how C is calculated. C is calculated by taking the total number of points that you can get for a question, split evenly amongst the number of true answers. So for example, if I have option A, option B, option C, option D, and in this question, I can get a total of 4 points. Let's say the correct answers in this situation were A and C. That means the total points get split up evenly amongst A and C. So each one would be worth 2 points. And then consequently, any other, if we went on and on forever and ever, A, B, C, D, E, F, everything, all of these wrong answers would count as -2. I should not make that look like a minus sign. All of the wrong answers would be -2. And so the points you lose for an incorrect answer is dependent on how many correct answers there are. And so yeah, so now you can probably understand why this is how C is derived. So if C is equal to that, we actually have P. But we don't know the number of true answers. But what we can do is graph every possible combination of X and Y such that this equation equals B. So such that this equation results in the points that you got. And then we can graph that X and Y, and you can get the number of false positives and the number of false negatives in the graph. So, okay, what does that look like? So imagine you have N, which is the number of answers that you chose. Okay, that's the number of answers that you chose. If we subtract from that the ones that you got wrong, that's X, and then we add the number that you didn't choose but they were right. This right here is the number of true answers given an X, Y pair. And so what we can do is put this back into the equation and write the entire thing. P minus the number of wrong, which is X plus Y, times C, which is the cost that happens when you choose a wrong answer. That is P over N minus X plus Y. And that whole thing will equal the number of points that you got, which is P. And so if we clean this up a little bit, you'll see that I can just do P minus PX plus Y over N minus X plus Y. And that equals B. And what you might notice, probably not because you just heard about this equation, but this is the exact equation that I use in the Desmos graph. And so what's going to happen is that even though we don't know the number of false negatives and the number of false positives, we can still graph every possibility of false positives and false negatives such that we result in the number of points that we got. And so there are non-integer solutions for X and Y, but those don't have meaning in the real world, or at least the problem that we're applying this graph to. So we are only concerned with the points when X and Y cause this equation to equal B, and when X and Y are integer values. So hopefully that clears things up. And you might notice that I have a lot of plus 0.1s and 0.1s. This is just to make the graph a little bit easier to see, because sometimes you can't really see an intersection if a line just barely goes through it, or if the area barely touches it. This just adds some leeway, like you can see right here, where my mouse is. This is all padding for an actual integer coordinate right here, 2, 1. To make it very obvious that this is an intersection, instead of this intersection being the corner of the area. So yeah, hopefully this made sense. I'll be going over it again and some other things in the other video. So cool. Hope this helps, and I hope you understand why it works the way it does.